Hello everyone, and welcome to another MLOps demo. This time for the week of November 15th, 2021. This week we have very exciting updates regarding Jupyter Experience and also some updates on exploration for pipeline runners for machine learning. So first of all, it has been the diffs have been integrated into the code base, so it is already in production. It's still behind a feature flag, and it's only available for some specific projects on the GitLab organization, but it can already be seen in the wild. So for example, now we have this is already on production. This is public, anyone can take a look at this. This is how a Jupyter notebook is being rendered for new commits. You can see that we also added code highlighting for Markdown, so it's a lot easier to parse even. There are things we can still improve, a lot of them, but we already have this. So for comparison, this would be what it would look like otherwise. So let me open up this here. New commit. No, not this one. So let me open the history and the first commit. So this is what it looked like before. You can't really make a lot of what is going on this notebook. However, this is the new one over here. So a lot easier to parse, a lot easier to comment, to discuss. But before we publish this to all repos within the GitLab org or to GitLab itself, we still need to fix one bug that is quite problematic. That if you try, since we are rendering this diff, if you try to add a suggestion over here and you just change anything to, I don't know, blah over here, and you add the comment, this will completely break the notebook. If you apply the suggestion, it will become an invalid notebook, and it's not really a good experience for the user. So what we'll do, we'll disable suggestions for now for Python notebooks. We have ideas on how to fix this eventually, but for this iteration, we will not do that. We will just disable complete iterations, code suggestions for Jupyter notebooks. So what's next for this? Of course, after fixing up this bug, we also will do a cleanup of the code base. We had to add a lot of logins to figure out some additional bugs, but also we want to start working on a richer diffs. So right now we have cleaner diffs, but we want to do a rich experience for Jupyter notebooks. For example, we had this is not a really good image, but if this was a valid image, we wanted to display this along with the diff. Perhaps better not linking, but highlighting. So this is this is not really useful. This can be a little bit less visible or grayish, for example. So add a little bit more, a better rich experience for Jupyter notebooks within GitLab now that it's already cleaner. And this is for Jupyter notebooks, so very exciting. It is live, it is on the code base. It's still behind a feature flag, but it is there. Soon it will be available for everyone. The second update is that we've been, in addition to the Jupyter, there are many things we want to explore within the MLOps space. And one of them is how GitLab pipelines help machine learning users. And one of the ideas that we had was to try an experiment on hyperparameter tuning. So hyperparameter tuning is a process where you take a model that you already have, and this model usually has a lot of parameters for configuration. So for example, if I use a random forest classifier, I have number of estimators that I can configure, the criterion, max depth, mean samples, and a lot more. And these affect the outcome of the model, right? What we want to do and you can optimize this value. The same way that you can optimize a machine learning model, you can optimize the algorithm itself. But this process is very slow. because you have to iterate over many times to find it's a search problem. So you can either go random search and just like grid search, try out all possibilities. You can do a little bit smarter search with Bayesian approaches, for example. But the point is that it's a search problem. It takes a long time and it's very repetitive. So it's very useful to have this as a pipeline. Kubeflow implements this with GitLab. It's a library specifically done for trying out this on Kubernetes, but we want to do something different and we want to try it out try just using GitLab pipelines for now. For now, I found out that it's impossible to run a loop on GitLab pipeline, so you cannot do the iterations as you would do normally. You could do random, not a random, but a grid search, which is try out everything. So you can use parent-child pipelines to try out every single possibility and get the results in the end. And this is what we're going to try first. So first, the thing that I did so far, I created a sample data set that has 7 features. And it has a equation that depends on the 7 features. And what I do, I just pick my data set, my feature data set that I have for this machine learning model has only 4 of these features, which means that it doesn't capture the whole equation in it, right? So I can try to build a machine learning model that tries to predict the final value. And I did this. It's a random forest model classifier. And okay, it achieves this accuracy on the default parameter. So the F1 score for this is 0.73. F1 score is a measure that balances how often it makes right predictions and how often it forgets to make a right prediction, basically. So here we start the parameter tuning. So we create a grid search, which grid search means we're going to try out everything, all the possibilities. So I would have here 3 times 2 times 2 combinations, which is 12 candidates. For each of the 12 candidates, I split the data 3 times to have 30, and I do 3 trainings. So only with this small parameter space, I have 36 trainings to be done. So you can imagine how this explodes very easily. So we do the parameter training over here. And we have the results, which are very not so much readable over here. But we have some plots here. For example, I plot over here the test score versus one of the parameters, which is max depth. Max depth of the tree is how many nodes, how many decisions each of the trees can make. But you can see that the higher results, although you have some outliers, but the higher results happen with a larger max depth. So you usually choose a larger max depth. Similar with max samples, you see that the scores here are on average larger than the scores over here. But with the mean sample split, it doesn't seem to change a lot. It kind of looks okay-ish. And you have this, this is a HiPlot, which is a interactive tool that it makes it a little bit easier to explore the parameter space. So here you have each line is an experiment with different parameters. And you see, so you see that for this over here, let me try to select this one. The best parameter that you found at 0.738 is 10. The mean splits is 10. The param is 500 max samples and the max depth is 10. So you can see where each of the parameters fall into this space and the combinations within the parameters itself. So it's a pretty cool visualization to have. Let me just select let me just unselect this. Okay, yeah, now I have everything. So yeah, so here I have all of the different, I have even the time, the scores, and everything for this. So this is a toy project that we can use now for implementing the pipeline. So the next steps that we have over here, now we have somewhat the code. Very simple, very stupid. It's not a real problem. This is a toy, one that but it's already enough to test out what we want to do. So the next step is find out how to implement parameter like the search problem within this this framework. And the cool stuff about testing out this hyperparameter tuning is that this paves the way for AutoML. You can think that even the choice of algorithm itself that you use for the machine learning model is a hyperparameter. So this hyperparameter tuning, you could add one step before or one step into the search that would be the one to identify what is the best algorithm for the data to have. So this is one. Making hyperparameter is about it's a good step towards finding out if you can do AutoML within GitLab or not with GitLab pipeline. So that is very exciting. Yeah. So next steps over here: transform this into pipelines. See if we can torture the offering the product enough so that it we can find something nice and what needs to be improved specifically for machine learning applications. I think that was it that I had for today. Thank you for joining me one more week, and until the next one.